Hi, so this is my presentation on Misconception Media. It's gonna be on Legolas Jumping on Falling Blocks by Ken Huang. Sorry, I couldn't really figure out how to get an application to record without that allows me to full screen. But yeah, we're gonna be watching a little short video. So as we can see here, he's kind of walking on falling rocks, which breaks quite of a lot of laws of physics. So what is being misunderstood here? Well, it's going to be Newton's first law, Newton's third law, the force of gravity, and the law of conservation of momentum. And I'm going to be talking about them in the next couple of slides. So Newton's first law states that an object at rest will remain at rest unless it's acted upon by an outside force, and also states that an object in motion will remain in motion unless it's also acted upon by an outside force. And we're going to describe how Legolas breaks this law. So I kind of drew a free body diagram, and we can see that Legolas, he is a stationary object on top of an object in motion, and they're falling down vertically. And for him to actually be able to jump off that platform, he has to be his own external force, because an object in free motion does not apply a force upwards. And that kind of doesn't make sense if you think about it, because how can he jump off a platform when there's there's nothing opposing him to allow him to jump? Yeah. This also kind of brings into Newton's second and third law, where the force acting upon an object is equal to the mass times its acceleration. Like I said, for the first law, every action has an equal and opposite reaction and force. And Legolas, yeah, he kind of breaks these laws by ignoring gravitational force, since both objects are in free fall and there is no force exerted on Legolas. So technically they're in the same state. And then here's a free body diagram of what should have happened. So as we can see here, I constructed a bit of a diagram, and I calculated the weight of the blocks and the weight of Legolas. And these are just like some averages I found off online, where Legolas is 5'11", and I just found the regular amount of kilograms that he's supposed to weigh for that height for a human, which is around 72 kilograms. And the blocks, they're like they're like castle blocks. They're stone blocks, and they're from the little video we just saw. I found that the blocks were about 1/5 of his height, which is about 0.217 meters cubed. And I took the density of stone, and that's how I found the weight. I mean the mass of the blocks. And then what actually should have happened is, since they're both free falling, they should be subjected to the same gravitational force, and there's no solid ground for him to push off of. So technically, he should fall straight down into his own demise. But would this be possible if we ignore some laws of physics? And to do this, I kind of timed how long it took him to cross the platforms. He jumped on about 13 platforms. It took him about 11 seconds. And I used the law of conservation of momentum to even see if it's possible for him to cross all the platforms within that time. So we're given his mass, and then I found the velocity of Legolas, the initial, by seeing him running, right? And the average running speed according to the government sites, it's about 2.7 meters per second, and I'm being quite generous because that is one of the fastest times, or velocity human can achieve. And I also calculated the falling platforms where it fell about 1 meter from the video that I observed. And that's how I got a negative 4.4 meters per second. From there, I assumed that the platform will be touching the ground. So the final position of the platform would be 0 meters per second. And then I just inputted the mass of the blocks and labelets basically. And from there, I was able to calculate that his final velocity after after the first block would be 0.5611 meters per second. And for him to travel the block distance of just one block, it would take him about 1.782 seconds. But since he jumped on 13 blocks, it would take 23.16 seconds, which is just the time I multiplied by 13. And this is assuming we're breaking a lot of laws of physics, as in the blocks, they're still like kind of falling. But yeah, he just somehow managed to jump on 13 blocks and reach the outer platform, which in the video took him about 11 seconds. It's not really possible because the blocks are falling, and if he's jumping on falling blocks, he would have to be much faster, and theoretically, the force he applies, it doesn't matter how much force he applies because he's in a free falling state. So yeah, he would just he would just fall straight down, and there's nothing he can do in a realistic scenario. And that's pretty much it. Here's my citations. I have 3 websites that I cited, and yeah, thank you.